Hello, welcome to today's class. Today will be our first class on artificial intelligence lab. And if we look at our syllabus, as per our syllabus, we need to learn a Prolog and Lisp. But as I had mentioned it before, and if time permits us, we'll also have a little bit. We'll have a look at a little bit of Python also. We will start with Prolog, and the textbook that we will use for Prolog is Prolog Programming for Artificial Intelligence by Ivan Bratko, and the software package that we will use is SWI Prolog. You can download SWI Prolog from this website, swiprolog.org, and if I would want you to show the website, and this is where you will find, this is where you can download SWI Prolog. And as you can see, SWI Prolog is available both for Windows and Ubuntu. And regarding installing for Ubuntu, if you follow this link PPA, you will get the instructions for installing SWI Prolog in Ubuntu. Now Prolog actually stands for Programming in Logic, so it's basically a logic programming, and it's a declarative programming language. More details of Prolog we will see in the next few classes. Today's class, my focus will be just to get started with using SWI Prolog. So for that, we will start with a simple example. Let's say we have a family tree as shown here, and we want to represent the knowledge of this tree in Prolog. So one way that we can represent these facts, these are facts that Pam is the parent of Bob, Tom is a parent of Bob. So these are different facts, and we can represent this fact in Prolog as relations. So here we are defining a relation called parent. You can give any name to the relation. Here we are using the name parent, and it's a binary relation because there are two arguments in the relation, and the meaning of this relation is that Pam is the parent of Bob. And similarly, the next fact, it says that Tom is the parent of Bob. Like that, we have 6 facts, and we can represent those facts using these 6 clauses. Relations in Prolog can be fact, or it can be rules. We will look at rules in the next class, or it can be questions. Here we are using the relations which are of type fact. Now it's important that you start with a small case letter. Similarly, the arguments should be small case letter. It should start with a small case letter, and every clause should end with a full stop. Now I can write this 6 fact in a file. Before I use this fact, let me show how to start SWI Prolog. I have already installed SWI Prolog in my machine. So now you can start as I am using the Ubuntu version. So once you install, I think in Windows you will get a GUI also, in IDE, which you can use. Here I have installed SWI Prolog in my machine, and I can now use SWI Prolog using this command SWI-PL. Once I execute this command, it gives me the command line, and here I can give different queries to SWI Prolog. But first let me show how you can exit this command line. You can type halt, HALT, full stop, and this will exit from SWI PL. Let me start SWI PL again, and now this sixth fact, let me actually exit halt. The sixth fact that we had, I can write this sixth fact in a file. In my case, I have written those six facts in a file called program01.pl. Let me show you this file. You can give any name to this file. So let me show you that file, vi program01.pl, and if you see this file, this is the content of the file. So in that file I have the six fact of the family tree. So now after you write down these six fact in a file, I can start SWI PL, and that knowledge that is embedded in that file program01.pl, I need to now bring it to SWI Prolog, and the way I do that is by using the consult command, consult, and you give the name of the file here. So the name of the file was program01.pl, and then you need to give the full stop. So now the knowledge of the family tree is available in SWI Prolog. Once that knowledge has been included, those facts are now has been included, brought into SWI Prolog, I can now give I can give some queries. So I can give queries like is Bob the parent of Pat? So I can give this query in SWI Prolog. Again, your query should end with a full stop, and it says true, yes, Bob is the parent of Pat, because as you can see, Bob is the parent of Pat, and we had a fact for that, Bob is the parent of Pat. Since this query can be satisfied using the knowledge that was present in this file, SWI Prolog is returning true. If I give a different query like is Liz the parent of Pat, if you look at the family tree, Liz is not the parent of Pat, and that fact is not present here. So if I give that query, SWI Prolog will not be able to satisfy it, and hence it will return false. Similarly, if I give a query like is Tom the parent of Ben, this object Ben was not part of our fact, so there is no object called Ben, and hence this query will also return false. Now I can also ask questions like who is the parent of Liz, and as you can see in this query I am using this capital letter X, whereas in earlier case we use concrete objects. Concrete objects start with a small case letter. Now this variable X, variables always, the convention is that you have to start with a uppercase letter. If you want to use, if you use small x, it will search for the object X. Just like we search for object Ben, we will search for object X if I use a small case letter X. Just like Ben was not present and hence false was returned, similarly if I use a small case letter X, X object is also not defined here and it will return false. However, if I use the capital X, now it's a variable, it's not a concrete object, it's a variable. So when what will happen when I give this query is Prolog will try to find out a value for X for which this will become true. So basically it means for what value of X this query will become true. Another way of saying is this is a goal and Prolog will try to find out for what value of X the goal will be satisfied. If it can satisfy the goal, the value for which the goal will be satisfied will be returned, and if the goal cannot be satisfied, then false will be returned. So in this case, is there a X who is a parent of Liz? Yes, there is a value for X. The value is Tom. So for X equal to Tom, X will be the parent of Liz. So if I give that command, it gives X equal to Tom. Similarly, I can find out who are the children of Bob. So in this query, I want to find out those values of X for which Bob is a parent of X. So another way of saying is I want to find out who are the children of Bob. So if you want to find out the children of Bob, this would be the query. And if we look at the family tree, Bob have two children, Anne and Pat. So two values will be returned. Let's run that query. I'll press enter. Now it returns the first children, the first child of Bob, which is Anne. And if you want to know more values of X, you have to press semicolon now. If you press enter, if I press enter, it will return only one value. Just now I pressed enter, so it gave me only one value. It did not show me the second value. I'll run that query again. It shows N, and now if I want to get more values, I have to press semicolon. So when you press semicolon, you get the next value of X for which this goal will be satisfied. So Bob had two children, and the name of those children has been returned. Similarly, I can find out all the pairs XY such that X is a parent of Y. So in this query, both X and Y are variables. So now Prolog will try to find out all possible value of X and Y for which this will become true. So for example, if we look at the tree, so for X equal to Pam and Y equal to Bob, the query will become true. For X equal to Tom, Y equal to Bob, the query will become true. So those values will be returned. X equal to Pam, Y equal to Bob, then X equal to Tom, Y equal to Bob. But you will not see a value like X equal to Liz and Y equal to Bob, because Liz is not the parent of Bob. So only those values of X and Y for which the query can be satisfied, only those values of X and Y will be returned. So I press enter. So it returned the first pair of XY. Then I press semicolon, it returned the second. I press semicolon, it returns the third pair of X and Y. I press semicolon again, fourth, fifth, sixth, and since there was only 6 fact, all those 6 pairs has been returned. Further continuing, let's say I want to know who is the grandparent of Zim? So if you look at the family tree, Zim is here. How will I know the grandparent of Zim? First I have to find out who is the parent. So Pat is the parent of Zim, and then I have to find out who is the parent of Pat. The parent of Pat is Bob. So I can say that Bob is the grandparent of Zim. The same is so I want to that is depicted in this figure. So I have Zim. So I want to find out who is the grandparent of Zim. So first I have to find out who is the parent. Let's say there is some Y who is the parent of Zim, and then for this Y I have to find out the parent of Y, the value X who is the parent of Y. In that case X will be the grandparent of Zim. So this query to find out who is the grandparent of Zim can be written as shown here. It's also here. So this would be the query to find out the grandparent of Zim. Let me write it down here. So what is the meaning of this query? The meaning of this query is find out the Y such that Y is the parent of Zim, and once you have that value for Y, for that Y you find the X such that X is the parent of Y. And if I run this query, it says that X is Bob and Y is Pat. Why is Y equal to Pat? Because Pat is the parent of Zim. And why is X equal to Bob? Because once we determine that Y is Pat, so Y is Pat, now I have to find out who is the parent of Pat, and it is Bob. So Bob is the parent of Pat. So as you can see, I found out the grandparent of Zim, and the grandparent of Zim is Bob. So another way of understanding this query is, so this is the query that we give, and the meaning of this query is find such values of X and Y that satisfy the following two requirements. What are the requirements? Y should be the parent of Zim and X should be the parent of Y. So meaning of this query is this, and that would give me the grandparent of Zim. Similarly, if you want to find out who are the grandchildren of Tom, so Tom is here. The grandchildren of Tom, so one of the child of Tom is Liz, but Liz do not have any child. So through this link I will not find any grandchildren of Tom, but through this other link Tom has another child who is Bob, and Bob have two child, Anne and Pat. So if I ask for who are the grandchildren of Tom, it will be Anne and Pat. So now the query for it would be this. So what's the meaning of this query? It says I want to find out all such X such that X is a children of Tom, and for all those X I want to find out the Y which are the children of X. So in that case the values of Y will be the grandchildren of Tom. The values of X will be the direct children of Tom. So now if I run this query, it returns the first value, X is Bob and Y is Anne. We get X equal to Bob because we know that Bob is a children of Tom, so that's why X is Bob, and we get Y because we know that Anne is a children of Bob, which means Anne is a grandchildren of Tom. Now I know that there is one more value, so I'll press semicolon this time. and when I press semicolon, you get the next pair of values xy. So the next pair of values xy is x equal to Bob, again because Bob is a children of Tom, so that's why I get the value x equal to Bob, and I get the value y equal to Pat because Pat is another children of Bob, and hence Pat is the grandchildren of Tom. I don't have any more pairs, so if I press semicolon, it returns me false, saying that there are no other values. We have only two values. So that's all for today I have. So I would request you to actually yes, I've covered this slide. I've covered this slide also. I don't have any more slides for today. So now I'd request you to first install SWI Prolog and then try out this example. That would be the first step. You can try to do that for today. After that, in the next class we will look more details about what is Prolog, what we mean by declarative language, and then we will look at another type of relations or clause, which are rules. So we'll see what is rules, and as you can see, this is mostly logic programming. So it's slightly different from other programming language. Here this Prolog is based on first order predicate logic. First order predicate logic is part of our theory also. So there we will study the theory behind how the goals are satisfied. So here we are trying to satisfy the goals, and how these goals are satisfied, we'll study them in a theory part also. So I'd like to stop here for today. Thank you. Bye.